Hey everyone, my name is Ronak back with another video, and in this video we will be learning the logistic regression Python implementation from scratch. We have learned how to implement a linear regression. In the similar manner we have to implement the logistic regression but with a little bit of twist. You'll come to know about that. So let's get started. So I'll be using the same example of the number of hours the student puts and the examination outcome that he or she gets, that is pass or fail. So I'll say, so first of all I'll import. So I am importing numpy for mathematical operation, and then I'll say x is equal to np dot array, and I'll fill my values. So dot 50.50, 1.50, 2.00, 4.25, and 3.25, and 5.50. And then I'll say ndmin, which is dimension, which is equal to 2, and I'll be reshaping this. So I'll say 6 comma 1, that is 6 rows 1 column. Similarly I'll make for y, so np dot array 1 1 1, and I also want the mean of those, so I'll say x mean is equal to np dot mean, and I'll say x. Similarly I'll take the y mean, so I'll say np dot mean, and I'll put here y. Yeah, we have it, and I'll say n is equal to length of x. Now let's start with the logistic regression. So I'll say class logistic regression, and I'll say fit, that is my first function for training, and then I'll feed x and y, so it takes two parameters. And then we will require two functions, that is upward function to calculate the value of beta naught, and I'll say downward function is equal to 0. And let's get started. So for I in range of n, that is 6, I want to perform something, so I'll say upward. So basically I'll be iterating the upward function as well as the downward function to get the values for the regression coefficient, that is beta 1. So I'll say x of I minus x mean into y of I minus y mean. Similarly I'll say downward function, and I'll just copy this thing, and I'll say raised to 2. Now I kick out of the for loop, and now I'll be using the values of the beta 0 and beta 1 throughout my functions. So I'll say like this, and I kick out of the for loop. Then I'll say self dot beta 1 is equal to upward by downward function, that is the formula. Okay, similarly I'll say self dot beta naught is equal to, well, self dot beta naught is equal to y mean minus self dot beta 1 into the mean of x, so x mean, and I return both of this. So I'll self dot beta naught and self dot beta 1. Yeah, so the basic structure is ready of our linear regression. Now the next thing that comes to mind is basically predicting. So df predict, I'll say, then I'll put self, and we'll put parameters accordingly. So now first of all we'll have to create z. So z is equal to my function of linear regression, that is self dot beta naught plus self dot beta 1 into x of I. So I'll have to mention x of I over here, so I say x of I, and now I'll be feeding this z to get the sigmoid, and then that sigmoid is going to interact with my ypred. So basically my ypred is going to be my sigmoid function. So I'll say let's say sigmoid, that is the name of the variable, which is, we can also consider it as a ypred. So sigmoid is equal to 1 by 1 plus mac dot e. Okay, I can do like this and then I can just raise to it, but instead what I'll do is np dot exp. So that is the Euler's number. So basically it is e. So e raised to np dot xp, and it basically expects the values. So I'll say z. Okay, you got that. And now I'll just return sigmoid. But we will have to also set the threshold, otherwise we won't get the value. So what I can do is I can say if sigmoid is greater than or equal to 0.5, that is the threshold that I'm putting, I can say ypred is equal to, let's say, 1. Else, so if it is lesser than 0.05, I can say ypred is equal to 0. Fine. And here I'll just return ypred. And now let us just test this. So I'll say model, which is the name of the variable, and I'll say logistic regression. Logistic regression, I make the object of my class, and then I can say model dot fit. So it is going to take two parameters, that is x and y, and I'll just print them to get the values of the beta 0 and beta 1. We have it, and then I'll say model dot predict, and it is going to take the value of x of I. So let's say the student studies for 2.7 hours on daily basis, and then we will have to find out. So according to the equation in the last tutorial, if you will calculate this manually, if you are about to calculate this manually, it gives us somewhere above 60. Okay, so it is something around 61% probability. So that is over my threshold, so the student is going to pass, and we have it. So yeah, it says the student is going to pass. See, because it is giving us 1, and the values that for beta 0 and beta 1 we are getting are overall same, and it says 61.4, that is 61% probability. So 61.42% probability. Similarly, I can say for 0.275, so it says 0 because the threshold is below 50% and the student is going to fail. Okay, so this example that I am taking is from my earlier tutorial. Okay, you can just check that for the example. So this is it, and let me show you one simple way from scikit-learn dot linear model. So linear model, import logistic regression, and then I can say LR is equal to logistic regression, that is making the object of my class, and then I'll say LR dot fit. So takes two parameters, that is my x and y data. Similarly, LR dot predict, and in the prediction mechanism I am feeding it 2.7. So it gives us array 1, that is the student is going to pass based on our data. Yeah, so this is it. And if I just comment out this for loop, so here I can say ypred is equal to sigmoid greater than or equal to 0.05, that is my threshold. So it is going to say false. So if it is 0, it gives us false, otherwise it gives true. So that is the reason I have selected this if else loop to match our data needs. Okay, so it is going to match our model, that's it. And if I change it over here, if I say 0.755, I get it as 0, that is false. Yeah, so this is it for this tutorial, and in the next tutorial I might go much deeper into the logistic regression function. If you want to access this notebook, you can have it on my GitHub repository. The link will be down in the description box. And a prerequisite for this tutorial is definitely going to be Python and the logistic regression intuition. If you don't know, if you know the intuition, you can apply this one easily. This is really easy because this is just raw Python. Okay, the only library that I might be using is NumPy, nothing else. That is the mathematical library, I would say. Yeah, so thank you for watching. Goodbye.